In today's video, we're going to graph using transformations, and we're just going to talk about two different types of transformations, a vertical shift and a horizontal shift. So first, we're going to start with the vertical shift, and we have the function f of x, and when we add k to the output for f of x, it is a vertical shift up k units when k is greater than 0, and down k units when k is less than 0. So for example, if I have f of x equals, let's say, x squared plus 2. This is a vertical shift of the graph of x squared up 2 units. However, if I have, let's say, f of x is equal to the absolute value of x minus 3, this would be a vertical shift of the absolute value function, the graph of the absolute value function, and it would be down 3 units. So again, you would take the absolute value of your input, subtract 3, and that would produce a downward shift k units. For these two problems, we're going to use transformations to graph the basic function x squared, which is our square function. So what we should do is start with the graph of the basic function. So I have 0, 0, 1, 1, and negative, positive 1. And when I graph that, I get a sketch of a parabola. Now here, we're going to then take each point and we're going to shift it up 3 units. So I'll go ahead and do this in red to differentiate between them. But I'm going to move every point up 3 units. So I have now 0, 3, 1, 4, and negative 1, 4. And now this is my final graph after the vertical shift up 3 units. For the second problem, however, I've got a minus 2. But we start the same. We graph our basic function, which is x squared, so 0, 0, 1, 1, and negative 1, positive 1, again creating a parabola. From here we will then move down, each point down, 2 units. So 0, negative 2, 1, negative 1, and negative 1, negative 1, still producing a parabola. Next we have a horizontal shift, and notice the notation is a little different. We have f of x minus h is a horizontal shift of f of x to the right h units when h is greater than 0, and left h units when h is less than 0. I really want you to focus here on the fact that this is x minus h, which means when h is positive, it will be x minus that value h. And then when it's negative, it'll be the double negative and make it positive. So that might have been really confusing. Let me give you a visual. Let's say f of x is equal to, let's just say absolute value of x. So f of x minus 2 is really equal to the absolute value of x minus 2. This is a horizontal shift to the right 2 units. And I know you're thinking, well, but it's negative. Well, the general form is always negative. So therefore, this is a positive 2. We put that in for h, and it becomes x minus 2. Likewise, if we have, let's say, f of x plus 3, same basic function, this is actually, because h in this case is negative 3, this is actually a shift left 3 units. So you can think of it one other way. Remember, x minus h is the general form. If h is negative 3, it then creates the double negative here, which then gives you the plus 3. Okay, we'll practice this in a couple problems. Same directions for these two as with the first ones. We're going to go ahead and graph these using transformations. Now notice with this one I have absolute value of x, and so we'll go ahead and graph the absolute value of x. We'll plot 0, 0, 1, 1, and negative 1, positive 1. Now remember this graph produces a v. Then we recognize the shift, or in this case it's going to be, since it's minus 3 inside the function, that means it's actually to the right 3 units. So I'm going to take each and every one of these points and move it to the right 3 units to get 3, 0, 4 comma 1 and 2 comma 1, and so here's the resulting graph. The last problem is asking us to do two transformations in the same problem. So what I'm going to do again is graph the original or basic function, the square root of x, which then means I'm going to graph 0, 0, the origin. I'm going to graph 1, 1, and I'm going to graph 4, comma 2. This will produce a curve that looks like this. From here, however, I have two shifts. I have the plus 1 and the minus 3. Now, it doesn't really matter which one you apply first or second. It really doesn't. But you have to identify them correctly. So the minus 3 means down 3. But the plus 1 means actually left 1 unit. All right, and again, that's confusing for some people, but remember, the form is always x minus h, so in this case, it'd be x minus a negative 1, which would result in x plus 1. And that's why we know it's to the left 1 unit. Let me go ahead and erase this work and plot the graph. So it doesn't really matter which one we apply first or second. I'm going to go down 3 units first, so down 3 units. Now I'm on 0, comma negative 3. But I'm going to go to the left one, so now I'm on negative 1, comma negative 3. Again, I'm at 1, comma 1, go down 3 units, and then left 1, and I should be at 0, comma 2. Finally, 4, comma 2, I'm going to go down 3 units, and then to the left 1 unit, and so I should be at 3, comma negative 1. This again produces a graph that looks about like this. Okay. So that would be a problem where we have a vertical and also a horizontal shift. I thought I'd do one more problem, and in this problem, we'll call this number 5. In this problem, I'm giving you the basic function, and in this case, it's a cubic function, f of x equals x cubed, and I would like you to write the new function that is represented after you shift it down 4 and to the left 5. So in other words, I'm not asking you to actually graph this. What I'm asking you to do is write the new function that would be represented after these shifts. So you write f of x is equal to, and remember, the left and the right should really come first. You should think about those first, and since it's left 5, I'm going to write x plus 5. Remember, plus 5 because it's actually x minus h, and so if left is a negative number, that means it's negative 5. And so I'm going to have x minus negative 5, which then is x plus 5. So that's how I knew this was x plus 5. Now, we always put parentheses around the x minus h, and then we apply whatever the function is asking us to apply, whether it's absolute value, squaring it, square rooting it, in this case, cubing it. Now, the plus 4, or the vertical shift, always goes last. It's actually down 4 in this case, so it's going to be minus 4. But that always comes last, so in this case it's minus 4, and that's always after you evaluate whatever is special about that function, in this case the cube. So, final answer would be x plus 5 cubed, and then minus 4.